Okay, I think I'm live. All right, welcome back. I was going to cover a bit more stuff, but there's not that many people here, so I might change the order of stuff a little bit. If you can hear me, just type in the chat that you can hear me, so I'm aware that I'm not muted or something weird. Cool. All right, so first things first, I thought I'd have a look at this. Now, this question seems very difficult, but it's actually very easy. And it's about understanding the language and pretty much just understanding what a semicolon is in the program and how we can get around them. The mod operator is not too hard to get around. So the mod operator is very handy for odd and even. It's usually the way that you check if something's odd or even. So you go if, let's say we had a variable a, if mod 2, else. And that will tell us if it's odd or even because it gives us the remainder of 2. Okay. But we're not going to use that. We're going to do it a different way. Now, we don't really need anything other than standard I/O for this program. We're not doing anything magic. We're just checking if it's odd or even. So that's not too big of a condition. It's only really this one here. So we want to ask the user to enter a single digit and then print out if the digit is odd or even. So I'm going to just maybe make that a little bit smaller. So a bit of room. And now I'm going to put the basic stuff in my code. So hash include standard IO dot h. And then I'm going to write void main. Now, this will give you a warning, or you could write int. Either way, you're going to get a warning. There's no way around it in this case. So either way, doesn't really make a difference. This problem is manipulating stuff. So with our code, we've seen that a semicolon terminates the line. But we've also seen in our code that we can do stuff like this. So if I've got int a becomes 4, I can actually do a becomes 3 equals 2. And so you can see I'm doing an assignment in here, and I've got no semicolon. Okay? And this is perfectly legal. So the assignment always takes precedence here. We get is 3 equal to 2. So we've got around the semicolon part. So that was quite easy. And that's just understanding that, yeah, a printf or an if statement can basically let us do that. So I'm going to put an if statement. And the first thing I want to do is ask the user. So please enter a digit. So I can put my printf in here, perfectly legal, because printf returns a value. If printf didn't return a value, then I couldn't do this. So if printf was a void function, then this wouldn't be legal. But because printf returns something, I can actually check the value. So printf returns the number of characters written. So I'm going to write please enter a digit. So I don't need the semicolon, but I do need another bracket. Okay, and that line there lets me print to the screen without a semicolon. So that's fairly easy. Now we've got the hard line. So now what I want to do is get something from the user. So it specifies that it's a single digit. Now, if I use scanf, we return how many things are read. But if we use getCar, this only returns a character. Because it's a single digit, and this actually returns something, this one's probably better in our case. So I'm going to use this. So I'm going to write an if statement, just purely so that I don't have to grab anything. I'm going to write a printf. Okay. Now, the printf, we're used to writing a string there. Okay. So I've written printf blah. However, what is that? That's a caster. So I can put any pointer to a string here. It doesn't have to be %d here. I could have, let's say, car a hello, and I can actually write printf a because that is a caster. So I don't actually need the double quotes in a printf. And that's understanding that these double quotes give you a pointer to a character. I mean, yeah, a pointer to a character, which is an array, if you follow it down the line. And it ends with a null terminator. And that's where it knows how long the array is. So given that, I'm going to do something rather odd. So here, I want to get the input. Okay. But I'm going to put a question mark there and use the ternary operator. Now, this was covered very early on in the lectures. We haven't used it much in the labs because students get quite confused by this quite often. But it was in the lectures, so don't forget the exam's based on more the lectures than the labs. So we have the ternary operator. So we have condition, if true, if false. So if we have A is greater than 2, then maybe we return 4, and if it's false, we return 3. Okay? So we can do something like this. So W becomes 4 if A is greater than 2, and if A is less than or equal to 2, then W will become 3. And this is the ternary operator. All right. So I'm going to use that here. And in my true or false, I'm going to put a pointer to a character, which is going to be a string because it finishes with the null terminator. So I'm going to say the digit is odd /n. And then I'm going to say the digit is even /n. So I'm going to finish up my for loop there. Now, there is one thing that won't work here. Now, we can write an if statement without the curly braces, but you can't write an if statement before the end of a function without curly braces. So you need to put curly braces here. Okay? C gets confused otherwise. So we can just leave that empty. We don't care if it's true or false. We just want to do what's in here. So now I want to get the input. Now I can't use the mod operator. That would make it a lot easier. But what I do know, and I can, I'm thinking if I should make this easier or harder. We'll go the easy route, and then we'll go the slightly harder route, I think, because I think it'll make more sense that way. So in here, I want to get my character. Okay. Now that's not enough information for us. Now, my character is currently a character. It's not a number. So I'm just going to move some of this stuff over. So we've got a bit more room. So to convert a character into an integer, we can just subtract 0x30. And if you look on the ASCII table, you can see why. Actually, I might grab the ASCII table up. Come on, come on, come on. So we've got the ASCII table. And you can see here that 0 is hex 30. 1 is hex 31. So if we subtract 30, we get 0. If we subtract hex 31, we get 1. Or we could have subtracted 48 decimal. That would have been fine too. Now, so here we can now get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have to work out if it's odd or even. So let's have a look at the relationship between this and binary. So here we have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, oh, sorry, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. Now, does the binary numbers tell us if the number's odd or even? So look, I'll give you a second. Have a go at that. If you don't know, just don't know. Yes, so the last place is a 0 or 1. So we can do a binary and just look at the last digit. So I'm just going to write 0x1 here, okay? Or you could write 0b1, or you could write 1. I just put in hex because it's nicer. Actually, we'll do that, just to be nice, and make it even shorter. Okay. So if we binary AND it with 1, if I have 0 and I binary AND it with 0, I get 0 here. Now 0 is the false case, so it says the number is even. If I get a 1 here, then a 1 and a 1, binary AND, remember, So it only will grab that first digit. The rest will be zeroed out no matter what they are. Then this will be true. So it'll be odd. Then if I get a 2 and binary and, I look at this last digit and I get even. Now, one thing that we can do to make this even better is that we notice in our table 0 is decimal 48. 1 is decimal 49. 2 is decimal 50. 3 is decimal 51. We'll also notice that it is hex 30. So if we do our conversion, 0 becomes 0, 0, 0, and 3 becomes 0, 0, 1, 1. We'll notice that 0, the 0th bit, the least significant bit, is also a 0. So we don't actually need to subtract hex 30 here. We can actually just leave it the way it was. And I have no clue what layer I'm on. Meaning that we can get rid of, what the hell is going on? I'm just going to join some of these layers. And now we can move this back across. And delete that. Delete that. Come on, hurry up. Against this layer. Grab all that. Format. So we get solution, which is that. So there's nothing new here, but it does involve understanding the concept. And this is perfectly legal in C. Does that make sense? Okay. Cool, cool, cool. All right. So the second thing I want to look at is the print results in the assignments. So with the bonus, did you guys do the bonus with print results? Okay, how many lines was it? Okay, so you did it the ugly, ugly, ugly way. Okay, so I'm going to look at the bonus. I'm going to look at the print state. I'm going to look at the print results with the bonus. Okay, and we'll see how many lines we really should have for the print results, because a lot of people had massive amount of code. Okay, so I just noticed there's a couple more people joining. Just use the chat window, please. And we're looking at the print results for the assignment. Most people were able to do this fairly well, but they didn't really think about it. And this is something really important, that if I want a solution to a problem, I can hack it. Okay? I can brute force it. But it's not an eloquent solution. It's not a fast solution. It's not a readable solution. As I've shown before, if I want to add 4 to a number, so if I've got A, and I want to add 4 to it, I could always go A++, 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 A++. It does the same job, but it's slower, it's not as readable, it's not as eloquent, and it's not as professional. And so with these problems, if we want, we can brute force all of our problems. Anyone joining, please use the chat. If it's your first time joining, basically every time I ask a question, just give a response. Just say yes, no, maybe, I don't know, it's stupid, I don't get it, whatever. Just give some response each time, because it makes it easier for me to talk for hours on end. All right, so I'm going to have a look at the print results. It's still not the best solution, but given the tools that you have, I'm going to show you a nice solution. So we've got our print results. We have our result table, which is kind of important. We have our n, which is the number of components, and then we have our components. And that's an array. Or it could just be a pointer. Either way, it doesn't make a difference. So in this, the very first thing that gets printed and isn't looped is just printf /new line components. There's not much you can do about that one. Okay? And it's straight read-only text, so just put it straight in. It doesn't need to be stored anywhere. A lot of people try and be fancy and store this somewhere, but it's just straight text, so it's not really necessary. Now, I have a couple of variables. I have the component names and the values names. So I'm actually going to create an array, and you'll see why in a second. So I'm going to have a car component names equals R, C, and I. There was actually a mistake. This should actually be an L, but I'm just going to keep it the way that it is on the assignment. I forgot to fix that. If you want to fix it after the assignment, just change that to an L. And I'm going to create values. Okay. So when you are, this is something I explained last week, with any programming or mathematics, it is really, really good to find patterns, because patterns lead to algorithmics, and algorithmics lead to performance. So patterns are your friend. So I'm going to create 2 more variables. I know that I've got a 2-dimensional array, so I'm just going to create them both right now. And I need I and j. Okay. Now, I need to print the component names R, C, and I. Okay. So I'm going to create a for loop. And that didn't change my color. I want to change my color. And this goes from I0, I less than n, I plus plus. Okay? And in that for loop, we've got a printf. We have a bunch of spaces. Depending on if you did the bonus or not, you have to change that. And then we have a bunch of spaces. And then we have a line. Now, I'm going to write component names. And I'm going to put a square bracket. Now, I know this array here has 1s, 2s, and 3s in it. And to me, they just look like indexes offset by 1. So I'm just going to write components I minus 1. Because, let's say the first one's a 1. Okay, so components I, so the 0th index is a 1. 1 minus 1 gives me a 0. The 0th index of component names is an R. So it prints an R. The next one comes along, I get a 2. 2 minus 1 gives me a 1. So I get a C. Beautiful. These are all links, so they look like indexes, they work like indexes, so I might as well use them like indexes. So that's my loop there. And that's printing all the component names. Then I want to print out the big total thing. Once again, this is something you can't really get around. It's not something that's looped, so I'm just going to put it by itself. Okay, and that's good. That's fine. I'm happy with that. Then I need to go through everything in my results table. So I'm going to create a big for loop. So for I equals 0, actually I'm going to change color again. Let's go green. That's, yeah, dark green. All right, so for I equals 0, I know my results table on the, in terms of the rows goes up to 6, but I know that I need pairs of them, so I'm just going to go I plus equals 2. Okay? And this is handy because I notice the pattern that I need I and I plus 1 every time. And so I can just add 2 here. So the next thing I'm going to do is I need to print out the value names. So what I'm going to do is put /n, because we need to go to the next line. I'm going to put %c. Then, okay, I did something a little tricky here. So, I actually have a static in my code, so we can do the same thing. So I'm going to actually add another variable here. I did this slightly different, just because I didn't plan. I completely forgot about this. So I actually created consts for this. So actually, I might show you. So we use, so this is something extra, but we use our ohms and amps and volts quite often in our code, or at least more than once. So they are a good constant. So up above main, I write static const caster const measure out. And we've seen consts before. It doesn't have to be static, but considering it, so static just means it's local to this program, not program, page. file is the word I'm looking for. So you could have done this given what you know. There's a space before there. And that's ohms. Okay, so you can see that I've got this constant character array because these never change, so I might as well make it a constant because I don't want to change these. Now, const doesn't mean that you can't change it. It's just telling the compiler that you don't want to change it. As we saw last week, you can still force it if you want to be tricky. But this is stuff we've already seen. And I'm just making an array of these. So I'm going to put a string here. And I'm going to use them, okay, in my print function because I want to. Okay, so here I want my value names. Now I've got Z, I, and V. And I is counting up by 2 each time. So I can just say I divided by 2, and I know this will be fine. So 0 divided by 2 is going to give 0. That's the first one. For when I add 2 to this, I get 2 over 2, which gives me 1, so it'll print out the I. And then when I add 2 to that, I get 4. 4 divided by 2 will give me a 2, so I'll print out the V. Okay. And then my measure out, which is the ones up above, which are my constants. Just because I use them multiple times in my program, they don't need to be written more than once. And then I can use my measure out as well. So this will do the exact same thing. So 0 will give ohms, amps, and volts. Okay. So that's all good. Now I want to print out each of the values. So j equals 0. Stupid mouse thing. J less than n plus 1, because we also have the totals j plus plus. Okay, so now I'm just going through the whole table. So I'm going to do the bonus in the same step, and I'm going to write printf %c, close bracket, %.3e, close bracket, %c, close bracket, open bracket, sorry, .3e, close bracket, j, and then a line. So you'll notice that I've got these characters here rather than pluses or minuses. And you'll notice that I haven't used the plus flag to always show a sign here. Okay, so if you weren't doing the bonus, you just added the plus here. But I've got characters, and the reason is it's simple. Plus and minus are just characters, so I can print on my characters. So all I need to know is this result table I, j, less than 0. If it is, then I'll print a negative symbol. If it's not, I'll print a positive symbol. And because I don't want to print the positive symbol here, I can just use the absolute value function and just go result table I, j. Then I'm going to go to the next line. It's still carrying on. I'm just going to come back a little bit closer. And then result table I plus 1, because remember we're counting up by 2. J is less than 0. If it is, I print out a negative. If it isn't, I print out a positive. And then I just print out the absolute value. Then I come back here, I close off this, I close off this, I close off this, and that's my print result function. With the bonus. So, given that, try and see how I picked up patterns there and how I went about that. Because you can do the same thing. There's nothing there that you haven't covered in the subject. Okay? But you can see that it's a lot nicer of a solution. It's readable. I know exactly what's going on. And it's nice and condensed. It's not overly condensed as well. So you can have overly condensed code as well that's not readable. And condensedness does not mean performance in most cases. Most cases you're looking at conditions and loops. So yeah, that's 10 lines or so. So does that make sense to everyone? I know there's more people here. So if you're listening, please do use the chat. Just say yes, no, I don't know, it was boring, move on, whatever, anything. Wait for some yeses and then we'll move on to something else. Cool, cool, cool. All right. I'm actually grab a quiz question from ASCII, and then I'll just have 2 minutes. Let's fill up my drink again. Question. All right, so I'm going to put a question up for you, which I want you to try. This is straight from the quiz. So have a go at that, and I'll be back in less than 5 minutes. All right, we got some answers. Are we still going? Are we stuck? Are we bored? So you do have an exam coming up, so you should be able to do something like this fairly quickly. So let me know. Are you stuck? Don't understand? Still going? Etc. 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 Stuck. All right. So a question like this is perfect for a boxing pointer diagram. Okay. We don't have huge variables. We don't have a lot of variables. And there's pointers. So wherever there's pointers, box and pointer diagrams are kind of handy. Now, if I was in an exam, however, I wouldn't write my box and pointer diagrams exactly perfect. Okay. So what I would do is I draw a box. That's main, done. Then I get here and go, this is my array. And I've got 4, 2, 6, 1, 7. That's good enough. And I've got x, which is 0. And then I call this function. So I've got a function here. It's called func. I then create these 3 variables. So I've got p, which is int star. They're all the same type, so I don't really need to specify the type. They're all ints. So I'm just going to put a star there. And then I've got n, and I've got r. Okay. If this question said to do the box and pointer diagrams, then I would put more information. But if I'm just quickly going through it in an exam, I'm not going to bother with that. So I pass my array. So I've got a pointer to the start of my array. I've got a 5, and I've got the address of x. Okay, pointer to non-pointer, perfectly fine. Then I get to this line, I introduce a new variable, so I've got I. And I takes the dereference value of p, so I follow my line, grab the 4, now I has 4 in it. I dereference, I create a pointer, q. Okay, I've got int star, and this takes the value of p. So now I've got another pointer to the start of my array. I then dereference r and set it to 0. Well, it's already set to 0, so that didn't really do much. And then while p is less than q plus n. So p is an address. I'm going to treat it as being address 0. While it's less than address 0 plus n. Now this is pointer arithmetic. Because I'm in an exam, I'm just going to plus 5. Okay, so I'm just going to say 0 is less than 5. I'm not going to bother timesing it by 4. Now, if dereference p is less than I, so dereference p, 4 is less than I. Well, that's not true, so skip over that. And we can increment p, so we move to the next spot. Okay. So p is now address 1. It obviously would be address 4, but I don't really care. In this case, because I know that they increment by 1 spot anyway when using pointer arithmetic. So it's still less than address 5. So I get here, dereference p is 2. Is 2 less than I? Yes, it is. So we come here. Okay. So p minus q, so p minus q is 1. Okay. And we've got dereferenced r. So this becomes a 1. We then go I becomes dereference p. So I now becomes 2. By now we can probably work out what's going on and just go to the end, but we'll keep going. So plus plus p, this is 2, fine, keep going. Is dereference p less than I? 6. Is 6 less than 2? No. Did we miss something? I don't think so. Sorry. So we've got, is 6 less than 2? No. So keep going. Then we get to our 1. So we have 1 here. Is 1 less than 2? Yes, it is. So p minus q is, we've got 3 minus 0, so we get 3, and that gets stored in dereference R, so x has 3 in it, and I has dereference p. By now we should probably just go, okay, 7's not going to be less than I, so we then end our function and go back up, because we know that none of this is going to be true and the next iteration is going to be 5 anyway, so that's all gone. And then we print 3, and we've got 3 as the answer. Okay? So I did that fairly quickly, just because if you're in an exam, you need to keep your pace up. But a box and pointer diagram gave me the answer, and that is the right answer. Okay? And you can always double check it later in the exam if you finish early. Okay? Does that make sense? Or is there parts that didn't make sense? Now, you'll probably notice that when we reach this point, okay, as I said, we'd already worked out the pattern. It's looking for the smallest digit, which would be the 1, and all it's doing with this x is finding the difference between the start and the smallest digit. So on the very second iteration, or if we read this, we could have gone, okay, it's 3, and not even bothered going through the other loops. Okay? So just say yes if that makes sense, or no, or maybe, or if there's a certain part of it that doesn't make sense. And then we'll move on to struts. All right. So we talked about struts this week, and this, what I'm going to cover now, isn't in the lectures, but it's going to help your understanding a little bit. So this part is, so we've seen size of. Okay, what does size of do? Come on, easy question. So you're kind of right, but your wording's kind of wrong. And what if I did something like this? Will that work? So size of has nothing to do with malloc, okay? Okay? It has nothing to do with malloc. Size of you can use in any way you like. It's handy for malloc, and it is useful for malloc, but it has nothing to do with malloc. Okay? It has nothing to do with memory allocation. It's just getting this. So it just returns size of a type or variable. Okay? So if we're using a 32-bit system and we have 32-bit ints, then W will hold 4 because it gets size of A is an int, and so it will return 4. If I put size of int in here, same thing, it will return 4. Okay? So the reason we're using it in malloc, you should understand, is the fact that we want a certain size of the type. It has nothing to do with the memory allocation part. It's just that we want 4 ints. So we need 4 times 4 because I want 4 bytes. Okay, but it doesn't have anything to do with the actual memory allocation. It doesn't do memory allocation. It just gives you the size of things. Okay, so if I did size of car here, what would W hold? Cars are always 1 byte, no matter what the system. For C, if you're using Java, it's 2 bytes. Oh, actually, it's a 32-bit number. Sorry, but for C, it's always 1 byte. If it was a short, then it'd be 2 bytes. Okay, you do need to know that for the exam. Okay. So you should know what a car is at a minimum, because car is a very fundamentally important type because it is 1 byte. Okay. All right. So that's all good. Okay, so we're all happy with size of. All right. So if you get an exam question, what does size of mean? You can do that and give an example. Okay, but that's not what I am showing you that. So I'm going to create a struct. Struct. C student. Okay. And I'm going to give them a letter grade. Actually, no, I'll give them an int student number. And a car for letter grade. I'm going to give them another car which indicates they're paying. size. What's of the memory? What memory are you referring to? So it returns the size of the memory to hold a particular type of variable, but the memory is not enough information. Or even better, we could say in memory. But you should specify, because one special thing about size is that it accepts a type. A lot of things don't accept types. Okay, so mentioning that it can accept a type is kind of important. So I'm going to give them a character based on their pain level, and I'm going to give them an int based on how much, based on can we do the one we did in the lab? No, we've already done it in the lab. So I'm going to create another int, and it's going to be the grade in percent. Okay. So I've got a bunch of members inside my struct. Now what I'm going to do, I'm going to write int name, and I'm going to write a printf statement. I'm going to write two actually, just to double test you. I'm on a 32-bit system. I'm going to put %d size of int. I'm going to put %d size of struct C student. Now that's a type, so that's perfectly legal. Okay? As we said in the labs, struct and the struct name, they both need to be together. They should never be separated, unless using type defs, but you're not. Okay? So, tell me what the size of these are. You do it fairly quickly, it's not a hard question. Hey, we've got a whole heap of other people now. So if you're just joining, say hi in the chat and I'll get you up to speed. I have to know where you got 26 from. Where did you get 26 from? Tell me, please. Where did the 26 come from? Where? Ah, 26. Okay. Cool. We just did. So if it's a 32-bit int, what size is int? We just did it like 2 seconds ago. 32 divided by 8 is 4. So give me a couple more minutes. So the first one's definitely 4, okay? Sorry, fix that up. Tell me what you get for size of struct. And anyone just joining, please use the chat. Makes it easier for me to stay around. Makes it hard otherwise. So have we got an answer? Give you a couple more minutes then. What happened in the chat? So as I said, if you don't know, say don't know. I'll say something because I feel like I'm talking to myself otherwise. Yeah, I got your answer. Just maybe the other guys. All right. So you are likely. Okay. So this one here is obviously 4. And the logical answer would be 10 for this because we go 4 plus 1 plus 1 plus 4. And we get 10 in our heads. But when we print it out, we actually get 12. So this is something that can confuse a lot of people. And the reason I want to show you is purely because of that reason. And I'm going to do one other thing. I'm going to create another struct. And I'll call this eStudent. And I'm going to go car letter grade. And I'm going to go int student name number. Then I'm going to go car pane. Then I'm going to go int grade %. Okay. I'm going to print this one out as well. So just remember, this one here is giving us 12, even though we expected 10. And now we're going to print out struct eStudent, the type. And I add these up again, and I go 1 plus 4 plus 1 plus 4, and I get 10. But here, I get something even stranger. And I actually get 16. And so at this point, you're probably scratching your head. They're both storing exactly the same thing. But the ordering of these has changed how big the size is. Okay. So this can be quite confusing. Okay. And this is called struct padding. So we're now going to have a look. There we go. So we're going to have a look at this in memory. Okay. So on a 32-bit system, this is what it's going to look like. So remember I said it's going to print out as 12. Okay, so I draw 12 bytes out. And these 4 here are the student number. This one here is the letter grade. So it looks pretty normal now. This one here is pain. Then it skips 2. And then it goes here and goes grade percent. Let me give this. That's a horrible color. These 2 here are padding. Okay. So with variables and with types and on a computer that's 32 bits, on the bus it actually has to send 32 bits each time. So it firstly likes to align the data so that it's in blocks of 4 where it can. On a 32-bit system, if it was on a 64, it'd try and align it so that they're in blocks of 8. And because of this, because we have a 4, then a 1, then a 1, and then a 4, because it can't align it, it adds 2 of padding. Okay? So we get 2 padding here, but it maintains the order that we put it in. However, in the second one, we have car letter grade. So I said that one will produce 16. So we'll have a look at that as well. And you'll notice that even myself, because of doing this, you'll notice that even I will think like a computer and try and block things in 4s, just because it's so natural when working with computers. And so the computer's basically doing the same thing that I am there. So the first one is our letter grade. Then the next type is an int. So that's not going to fit in these 3. So this one's padding, this one's padding, this one's padding. These are all padding. The next one is student number, which is an int. The next one is pain. And then we get padding. And the last 3 are going to be the student grade percent. So we saw here that changing the ordering, even though they have the same type, actually change this. Now, if I had, let's say, 60 million structs in an array, this could be quite a significant difference. Okay, so if I had 3 gigabytes of this struct, it would take 4 gigabytes to store the same thing of this one. Now, this isn't covered in the theory of the subject, so it's not examinable, but it is something quite neat and something quite useful, especially if you like using size-of operator, and some people do in this subject. It is handy outside of the subject, but if you like using it for testing what's going on in memory, especially with pointers and pointer arithmetic, the size-of can actually be quite helpful. Does that make sense? Okay. If it doesn't make too much sense, it's not a huge deal. As I said, it's not an examinable topic, but it's something that I find interesting. All right. So I'm going to show you another thing with structs, which isn't really examinable, but we did actually do it in the lab. And we kind of were a little naughty there. So I'm going to create this struct. I'm just going to call it struct A. I'm just going to give it a generic name because I can't be bothered coming up with examples. And I'm going to put an int x, int y here. Okay. Actually, no, I'm not. I'm going to, oh yeah, I'll put int x and y, and I'll put int star w. Okay? Because we all love pointers. So I'm now going to go into main. And I'm going to write a little bit of code. Stupid pen thing. So the first thing I'm going to do is I'm going to create a new variable called A. And then I'm going to go A becomes pretty easy stuff. Then I'm going to create a struct A. And I'm going to give it a name. So I'm just going to call it happy var. And I'm going to give it some values. So happy var.x is 2, happy var.y 3. And then I'm going to go happy var.w becomes malloc. Now, using malloc with a constant isn't usually a good idea, but I'm doing it in this case just for the example. So usually you want this to be a variable, or if it's not variable, you should really be using the stat. So just doing a normal array. But I'm not going to do that in this case. I'm going to put 2 here. Okay. So I've got an array of 2 ints for my w, and I'm going to go happy var.w 0 becomes 1, and happy var. Yes, you can actually have function struct prototypes, and you can declare structs inside of functions as well, but it means that they're only limited to that scope. You can also declare functions within functions as well, but they're only limited to that scope. Generally, for structs and functions, we want them for the whole program, and it gets a little messy. So generally just declare the structs above main for now. There are special cases where you'll have to declare functions or structs inside functions, but for now we don't need to. Okay. And I'm going to set that to 2. So this is all stuff we've seen before. There's nothing too complex there. All right. And I'm kind of on a drunken angle. And I'll grab that. Make that a little bit smaller, just so I can get some more stuff in the screen. Down a little bit. Down. Okay. So we've got our struct, and I might actually draw a diagram of this. So we've got A, which is an int. It's got 4 in it, and then we've got struct. Now, with structs, my standard for this is usually this. It gets a little bit messy, but with a lot of the box and pointer stuff, there's no real standard, and so a lot of it, the basic parts, there's a standard, but for things like arrays and stuff, there isn't. That's why I'm using one of my standards for that. And same with this. So X, Y, W, this one's an int, this one's an int, this one's an int star. Okay, so we're currently looking at this line. We set X to 2, we set Y to 3, and then we allocate some memory. Oops. Type int, and there's 2 of them, and we get a pointer back. So this just points here, and then we set 0 to 1 and W to 2. Okay, so you can see how a struct has a lot of variables inside it. And this is a reasonable way to view it. But you'll notice that it acts like a normal variable. It doesn't act like an array, it's not a pointer or anything weird. It acts just like this variable, except for it has members inside it. So anything you can do with a normal variable, you can do with a struct, but you can do more with a struct as well. So it's like variable plus. It's super variable. Okay, so does that make sense so far? Okay, so I just want to go over some very basic things because I noticed someone made a mistake here today. It's a pointer with it. No, it's not a pointer. It's just a variable. It's not a pointer at all. It's a variable. So A is an int, happy var is a struct A. It's a variable that we have created. It's not a pointer. Okay? It is not an array. It's not a pointer. It is a struct. Okay? It's as much of a pointer as this variable is as this variable. It acts exactly the same as any other variable, except for it can access members within itself. Okay? Now, let's go over some really basic stuff because someone made a mistake with this today. What is circled doing? Come on, this is extremely basic. Declaration. Declaration of what? So we're declaring an int of name A. Okay. Cool. So what does this line do? And everyone should be able to answer this. There was an exam question last year, I think, where it just pointed to certain lines and you had to explain what it meant. This is why I'm kind of doing this. And so I'm going to randomly do this. So, okay. So we've got the assignment operator here, don't we? Now, yeah. So it assigns A the value of 4. So what happens in this case? Beautiful. So what happens on this line? What is the assignment doing here? While you answer that, I'm just going to introduce another variable as well. Struct A set. Pretty sure it's black. So what's this assignment doing? If you don't know, they don't know. This one. I'm pretty sure this was a question on the assignment, wasn't it? So you should easily be able to answer this. So I hope you don't say I don't know, but if you don't know, just admit it. I should change this as well. Reserves memory for M. Assigns a pointer to the block of memory. Assigns a pointer to the block of memory. The function. No. Okay. So let's have a look at this. What does malloc return? It returns the starting memory address. So it assigns the starting memory address of what malloc returns, or you could talk about malloc in that. So it returns the starting memory address of some dynamically allocated memory, and that is stored in W, or happyvar.w. Okay? So it's that address is assigned to happyvar.w. All right? So we can see with this assignment, it's just moving one value to another place. Okay? Even this big malloc, it's just still one value. It's the address of this. In this, it's just one value. It's the 4 going into the A. So what happens on this line? So this one now. What's this one do? So I know this one's assigning the starting memory address of some dynamic memory to happyvar.w. Now I want to have a look at this one. So tell me what this does. So just be careful saying W, it's not W. It is actually part of the structure, so it's happyvar.w. W doesn't exist. W is not in scope. Because W is a member. So element 2 of happyvar.w gets assigned the value of what? Or of what holds. Just fix up your description a little bit. The first element? It's the second element. I would say using the number 4 is kind of bad here because it doesn't really describe what's going on there. You're using a variable for a reason. So I would say happyvar.w. So index 1 of happyvar.w is assigned the value stored in A. Okay. Because it's a variable, I probably wouldn't use the value, or I'd put the value in brackets. Because it is a variable. So saying it's 4, it doesn't really describe what's going on here. It's the value in A that is assigned, not a 4 that's assigned, because it could be any value that's in A. Okay, does that make sense? So index 1 of happyvar.w, okay? And it's not the first element, it's the second element. Okay? First, second, index 0, index 1. All right. So you'll notice that it passed one value into here. So it's pretty easy. We're just moving one value around. Explain what happens here. give your description, what you'd write on an exam. So write your little definition. I'm waiting. Come on, give it a go. It's probably, you know what the symbols are, you know what's on what side, and which goes where. Hopefully you can still hear me. Give me your answer, and we can keep moving. It's not standard. It's sad. There's happy var and there's sad var. Okay. So this isn't examinable, but as we saw, assignment assigns one side to the other. However, this is actually a shallow mem copy. Because you're going from a struct to another struct, we can't pass one value in. So this is no longer really an assignment, rather a shallow mem copy. Now, the difference between shallow and deep, I'll show you right now, but a mem copy is basically this. Whatever it is, give me 2 seconds. That's what I thought. So mem copy looks something like this. So just remember, this isn't examinable, but it is quite interesting and useful. Size of struct A. Okay, so basically we're copying this into this of size this, and it will just grab the big block of memory, wherever it is, and plunk it somewhere else. Now this is a shallow copy, and I'll show you what I mean by a shallow copy. So when I do this, I create my sad var. I'm running out of room. So I create my sad var, not standard, it's sad, okay? And I create my 3 variables within it. And I've got X, Y, and W, and int star. And I've got int, and I've got int, and I've got sad var, sorry, and it's of type struct A. Now, because this does a shallow copy, so it does basically a direct copy, and I did this the wrong way around. It doesn't make a difference, it just means that I want to initialize it. Either way, the example still holds. It's just this way I can show you why a shallow copy may end up with problems. Okay. But either way, it would have worked. And it still did the same thing, except that we'd lose all this memory and we just had uninitialized crap in here. So, it is a mem copy, so it just basically copies what's exactly in memory, except for the buffers, which is kind of interesting. But either way, so we copy the 2, we copy the 3, and we also copy the address. So what do you notice? With a shallow copy, we don't get our own copy of this. It just copies the address here. So with a deep copy, however, which you'd have to write a function for, you would get your own bit of memory here. So this can be kind of dangerous if you're not careful, because even though you make a copy, every time you change W, you're changing the W of this one as well. Okay, does that make sense? Okay, so if you see this, just keep in mind that it isn't really an assignment, it is a mem copy. It's still referred to as an assignment, but it really isn't at the same time. So just be aware of that. So let me know if that makes sense, and then we'll go on to something else. And as I said, this stuff isn't examinable, but I think it's very useful to know, considering you're keen to learn more by being here. I think it's good to show you how things really work. Even though C is very complex and there's no way we can show you everything, and I don't know everything, and no one really knows everything at this stage. But so some cool things. And as I said, I'll try and run a short course after to show you some cooler things. All right, so what we might do is have a 5-minute break. So have a little quick break, and I'll come back and we'll start another topic for about half an hour, 40 minutes or so. Yeah, get your drinks and stuff. Okay, so I'm back. So just continuing from the chat. So damn it, I want that copy. Let me get the graph up. Actually, maybe I won't put it up there. I might just put it in the chat for you. So that's for you in the chat. Anyways, the other thing that was talked about in the chat is how many labs are left. So I've said 4, and this is correct. So I've organized for another lab in week 13, which will be exam revision. It's not an accessible lab, but you'll want to be there. I haven't worked out the details of that yet. I've got the sign-ups set up, but I need to work out the dates. And they will go for 3 hours. And they'll be very packed labs as well. So they'll be full labs. I've started to book the rooms. Should get onto that. Okay. Okay, cool. All right, so at this point, we should be starting assignment 3. So I've got 3 submissions so far, which is excellent to see. And from this, let's go have a look at it. So ideally, you should have, I think I just opened the wrong assignment. I opened up the wrong assignment. Good work. Good work. Why is it taking forever to download? All right, so we have assignment 3. Minesweeper. If you don't know what Minesweeper is, watch the video. It'll tell you the rules. If you want to play a game, you can click here and play a game. Okay. It's a classic Windows game from Windows 3.1, I'm pretty sure. And you're going to create this, but not with the graphic interface. So in this problem, we want to create a playable game of Minesweeper. You'll be allowed to choose the size of the board, the number of mines, the coordinate value to select, and select if you want to flag a coordinate. Okay, so in the game, if you have a go at it, if you haven't seen it before, basically you're trying to set flags and work out where the mines are on the board. The game starts as an unrevealed matrix as shown below. Okay, so unrevealed here, all of these are hidden. If you have a look at the original game, all of these are hidden. Okay, the more lighter colored ones. The ones in here are revealed. Okay, so we're using the terminology, and this changed like 4 times, but we're using the terminology of unrevealed and revealed. Okay, before it was uncovered and covered, but it got confusing, so we went with revealed and unrevealed. So if a coordinate with no mines surrounding it is pressed, then all other coordinates that surround that have no mines and so on were revealed as shown. So if I click 1, 1, so this location, and there's no mine next to it and around that coordinate, it's basically a 0 spot, and so all of these are opened. And we have the same thing in normal Minesweeper, where if I click on something like this, because there's no mines that surround its 8 partner coordinates, then they get opened up as well. Okay, and that's why we've got the blank spots. And we'll have the blank spots as well. Now, always with these, this isn't the ideal solution, but one designed to test your understanding. Okay. Stages. So, we have stage 1, stage 2, and stage 3. So, stage 1, create both the initialization functions, the printing functions, structs, macros, global variables, and the first 9 steps of main. So, this should be done as early as possible and fairly easy. Then you've got the make move and get move function and all of main. Everyone should get these 2 done. The last one isn't very long, but conceptually it may be slightly difficult. If you want to get over 90%, you have to have had this done. Okay? And you can't get any of the bonuses done without having this done either. Okay? So if you want a chance of getting stage 3 done, you need to start early. So ideally by the end of this weekend, have stage 1 completed. So you'll notice that we're using standard IO and standard lib. We're not using the math library. If you want to use the math library, you can, but it's not necessary. This one isn't very mathy like the last one. Rather, it's very spatial. So you're dealing with looking at coordinates and things like that. So we've got our 6 functions here. So we've got initialize mine board, initialize mine value, make move, get move, print mine board, and uncover zeros. We've got structs. As you can see, we've got a double pointer to a struct. Doesn't that sound fun? We've got a plain struct there. And everything else is fairly normal. We've got this get move, which is just forward pointers, which is fun as well. And they're all described as below. So as same as before, each of them are separated into their separate functions. Now, do not change the naming. You can change the naming, but you cannot change the types. And when I say types, struct gain is a type. Do not forget that. All right. The following structs are to be used. So you've got struct location and struct gain. Okay. So the location is talking about a particular location on the board. Okay. And you'll notice here that there's lots of locations, and some have values, some have 0 as the value, and they also will have a status. Okay, and we'll talk about this status byte in a second. And then we have the game. So the game gives us information about the whole game. So we have the width and the height of the game, the number of mines that are flagged, and the number of flags, because these might not actually be equal if you're flagging the incorrect things. Create a global variable, which is of type int and initialized to 1. Please give this a meaningful name. Do not call it global. This will track if the player has still not clicked on a mine. When selecting a mine, this will change to 0, indicating the game is over. So this variable here, the whole program can see, and it will stay 1, and if you finish the game with it still set as 1, then you've won the game. Then we define a bunch of macros. So this is your hash define. We've got mine, flag, and revealed. And they've got 0, 1, and 2. And these are going to be used as bit flags. So going back a long time, we used flags when we did the bit lock. So we're going to do something very similar here. And we've got our status byte. Okay, so that's 8 bits. We're only using 3 of them, but if we wanted to extend the functionality, we could. But the mine bit, if 1, indicates that the particular location contains a mine. We've got the flag bit, which indicates if the player has flagged this particular location. And then we've got the revealed bit, which if 1 indicates the player has selected this position and the contents. So if it's revealed, if that's a 1, then it's open. I wonder if I can. Now you can't have revealed and flag be 1 at the same time because that doesn't make sense. Okay, so let me just. No, I didn't want to do that. Yeah, cool. All right, so this is the game here. So yours, you're going to type the numbers, but in this one, you just press it. At the start, you just have to kind of choose somewhere random. In this one, if you right-click, you can flag. Okay, and you're trying to flag where there's mines. If you click on a mine, I can, you'll notice that the game ends. Okay, so we're trying to flag as many mines as possible. YouTube. All right. And these numbers here give us information about how many mines there are. So if I look at this one here, in the 8 surrounding, there is 1 mine. But because 7 of the surrounding are revealed, I know there's a mine here, and so I can flag it. If I look at this one, in the 8 surrounding it, there's 1 mine. That one's been flagged, so I know that one's free. Okay, same here. So I can just go through and play the game and try it out. Okay. If you have trouble, just let me know, and we can help you play a game of Minesweeper. All right. Does anyone have any problems with that? So if you are confused about the rules, just let us know, and we can show you how to play. All right, let me get off that. Cool. So where are we? So we understand what a mine is, we understand what a flag is, and we understand what revealed is. And they'll follow you throughout the program. So if you understand them 3 concepts, it'll make pretty much good sense. Then, the program prints to the screen the student number, name, and assignment number. Okay, needs to be printed like that. It needs the student number there. The student number is extremely important. Do not put your student number wrong, please. Okay? Don't cheat. All right. And there's a comment from someone there. I need to get rid of that. All right. Create the following variable as shown below. So creating a struct. Set both the mines flags and flags variable in the game struct to 0. Okay, you can do that. Ask the user to enter the height of the board and store in the game variable appropriately. So you get the width and the height using whatever you use to do that. Then ask the user for the number of mines and store in the game variable appropriately. You should also ensure that the number of mines is less than the product of the width and length. If it is not, then keep asking the user until it is. Now with this, we're going to be a bit harsher if you're not using the right kind of loop for this problem. Is it a do-while loop or a while loop in this case? Also, with your messages, it needs to be on one line ending in a new line, and you can choose the appropriate message. Then, create a pointer to a struct location. A pointer to a struct location is a double pointer. So struct location star star, as you saw earlier. Name mineboard and dynamically allocate memory of size of game dot height plus 2 multiplied with the size of struct location star. So you've got a pointer here. So this size of, in this case, isn't looking at the size of a struct location, but a pointer to that, okay? Which would be the same as any pointer size. This is the rows of your 2D array. Now I'm going to give an explanation this Saturday of why there's a plus 2 there, because it's not quite clear, but we'll get to that. And you don't really need that till stage 3 anyway, this plus 2. So it's useful in the stage 3, but you need it to create it now. And then you're going to iterate and create your columns. So I'm going to talk a bit more about this on Saturday in the help session, because this isn't the only way you can make a two-dimensionally allocated, dynamically allocated array, and there is actually slightly better ways. But this is similar to your assignment, your second assignment, in how you did that. Okay. I don't know why I gave you that. I should delete that. Then the program initializes the board using the appropriate function. Then the program prints the board to the screen using the appropriate function. And then you stop here. So you've got 2 other functions you need to do, so initialize and print. So initialize. So create some iteration variables, iterate from 0 to game height plus 1 inclusive using I. Then iterate again, so you're doing it 2-dimensional, and set the status byte for 0. Create variable temp mines and initialize to game.mines. Create variables x and y, and create a loop that continues while temp mines is greater than 0, and set x and y to random values as follows. Okay? Now you'll notice there's a rand there. Now this rand is not seeded, meaning that if you're using the Unix machine, you'll get the same values as me. Okay? Because it's not seeded, and I'll explain what seeding is maybe now. Okay. So you are using the rand function. I recommend you have a look at it, but you are not seeding it. And then test that the mine bin status byte given the x and y coordinates is 0. I don't know why I would do that either. If so, set the mine bin the status byte given the x and y coordinates and decrement temp mines by 1. And then you call the initialize mine values function. So now you've got to do this one as well. Okay. And so this is setting up the values. So iterating again and then checking if they're equal, else do this part. And we've got a print. Now I haven't told you much about the printing, So iterate through the locations. If it's a flag, set it to F. If it's revealed, then set, if it's a mine, to an M. If it's a 0, print a little line. Else print the value. Else print a hash to show that it's uncovered. Now there's a space before each of these symbols. Okay, so one before and one after. We're not doing that function yet. We're not doing that function yet. We're not doing that function yet. Okay, so that's step 1. So then 3 functions plus that. And that's what you should do by this weekend. Okay, and there's nothing too complex in there. Stage 2, you're going to implement this. So you're just given the diagram and you need to implement it based on diagram. Now, the diagram can be optimized as well. I gave you way too many hints. I might edit this. Then you've got your make move function, which is part of part 2. Okay. You'll notice that it doesn't give us much information here. And we'll notice that if it's stage 2, you leave it blank. If it's stage 3, then you come back and add the uncovered zeros. The uncovered zeros is the stage 3 function. Okay, so create a function that uncovers all surrounding coordinates. There are 8. If any of the surrounding coordinates are of value 0, that are not revealed, and that are not flags, then repeat either recursively or iteratively. This function should uncover groups of 0 values, and so you can refer to the instructions. Now, one big note, you do not need the size of the board to do this function, and this function is about 10 to 30 lines if done properly. So it's not a long function, but it is a little bit difficult to wrap your head around. And then you've got the get move as well. So you've got some constraints. Text needs to be easily understandable. You can change the text, but the same inputs must be used. Must print the student number. Types must be used appropriately, and you must use comments. Functions descriptions must be included, and program description must be included. Code should be around 250 to 350 lines. If your code is significantly larger, it doesn't mean that it doesn't work. You just may want to reconsider your approach, as we saw earlier with the example of assignment 2. You've got the problem, and then you've got the report. Now, just be careful on the report. I might change a couple of little things in that. Examples are given on LMS, and I'll put some examples up now. Can I? That's a big good question. Let me kill the stream if I do that. All right, I can't show you right now examples. Next time I'll remember to do that. And the bonus is going to give them the LMS tab. And then you've got your rubric. And yeah, it's a pretty fun assignment. It's not too difficult, but you can see that you're starting to lose the number of steps. Okay, if you go to the assignment tab, I'm starting to populate test cases, okay, and different test data. So if you want more examples, you can have more examples. I just finished writing an AI to solve all the boards. So you'll notice in the test cases, we've got both human players and AI players. My AI is a bit naive, so it won't always win, but Obviously, if you want AI, you don't want it always to win. But I've set up 12 test cases, and I can set up thousands more if you want. It's not hard because I don't have to play the game or get the AI to play the game. Okay. And you'll also notice that they're not all wins because obviously you want to test different things. So you'll notice this one makes several mistakes. This one makes several mistakes and loses. This one wins the game with no mistakes. This one makes several mistakes and wins, because I don't just want you to show you the perfect game, because obviously you want to see what happens and make sure that you protect from mistakes. Okay? So you'll have a heap of data that you can use to test your program. And I'll have videos with all these test cases up soon. But I can't show you them now because I'd have to connect to the server, and that'll probably kill the stream if I do that. So I won't do that now because I made edits today. Unfortunately for you. I might actually try right at the minute, and if it kills the stream at the end, and if it kills the stream, it kills the stream. If it doesn't kill the stream, it doesn't kill the stream. All right. So do you think you can get that done by the weekend? Not the whole thing, but stage one. And stage one's got all the steps. It's very similar to the last assignment, and so stage one's very similar in terms of main as the last assignment, and the other functions are very similar to the bitlock and things like that, different parts of the labs. Sound fun? So just say sounds fun if you're happy with that. It's possible. So give yourself a deadline. You will thank me later. You'll thank yourself later than trying to do it at the last minute, especially when other assignments are due and you've got exams coming up. You don't want to be doing this assignment on the last week. Just do it now. So one thing you've got to remember, that doing it on the last day or doing it several weeks beforehand, you use the exact same amount of time, and you probably actually use less time because you can get help pretty much straight away now, where at the end everyone's asking for help and I'm just can't be bothered dealing with that. So if you start it now, it'll actually be less time overall. Yeah. I'm going to get up. Something, where is it? So let's get up the information about the exam. Do you want to know about the exam? Or are we tired and don't care? There's only 3 people left. Maybe we'll go over the exam next time. It's up to you. I'm not going to go into huge detail, but give you some heads up. Exam. Failed to load. Yeah, exactly. But it doesn't seem to be loading. So I'm going to be writing a practice exam up for you guys as well when I get time. I can't go in another window. So we're not giving out last year's, but I'll write one similar to last year's. So be aware that the exams from what's it called? Before last year are very different than this year's and last year's exam. However, even so, you need to be aware that they're still helpful, and I will use them in preparing you, because they are excellent questions. Some of the questions aren't applicable, so this subject used to go a little deeper, but so it used to go a little deeper, but not very good in some regards to some of the other stuff. So what was I going to say? So there might be stuff on there that you may not understand because it wasn't covered, if that makes sense. So there was more topics in the past. Okay, I don't know where that is. Get this one up. All right. So in terms of the exam, and what you should prepare for. The 33%. All right, cool. All right, so there'll be questions like the quiz. Now, I would highly recommend that at this stage, try and do 2 weeks each week. So this week I'd do your normal quiz, and I'd also do at least 2 or 3 attempts of the 1 to 6. So if you haven't seen already, let's get this up. I can get this up quicker here. Come on, hurry up. So if you haven't seen already, if you go to the exam tab, go down the bottom, you can do practice of weeks 2 to 6. Okay, so there hasn't been many attempts. I would do at least 2 or 3 each week attempts. If it's really bad, maybe more, but get practice with this, because this will make a huge difference in the exam. Okay, so there'll be questions like that, and quite a number of them. So there'll be questions like the quiz, and then there might be questions that will ask for the output, so output-y kind of questions. So given this piece of code, give the output. The quiz will help you with that as well, because you're kind of doing that at the same time as doing the quiz. You're just not writing the answers, you're just clicking buttons. So the quiz is quite helpful in getting you prepared for the exam. Now, there is 2 big things that will be on the exam that you need to prepare yourself for. And these are the box and pointer diagrams, I can guarantee they'll be on there. And there will be also, which we use quite often, and it's in the assignment. And we'll talk about the bottom pointer diagrams as well, because it's actually a fairly difficult question, just in terms of time to get these done, because you have to draw a lot of them. So I think you do, well, last year's one did, I think they would have done at least 50 or so boxes, maybe a little less, maybe 40. And the big one that you need to start practicing, and a lot of people have stopped using, is the flow diagram. Okay, and we saw this very early on, I think week 2 or 3. And I've also got, if you go on to week, I can't remember where I put them. I put them around there somewhere. Oh yeah, so if you go on to week 7, you've got all the flow diagrams there. So I would revise them if I was you. They're quite simple. So you'll have to do something with them. So either drawing one or reading one and writing code from it, or interpreting, explaining one, or given a definition, a description of some code, you need to write a flow diagram. So all the symbols and stuff are there. You just memorize these. They're fairly easy. It's just like a flow chart. So yeah, that will be on there. Yeah. Other things that may be included. So this is a selection of things. Error messages. So error messages were on the exam last year. So you're given an error message from the GCC compiler, and you have to explain what that message is telling you and how you would fix that problem. And this shows that you understand the theory, because the labs teach you the practical, but to read an error message, you need to understand the theory. Okay. Other possibilities are explain particular lines of code. There's one other thing. So you're just given like a big thing of code and you have to explain, oh. And there's another one, which was, I can't remember what it's called. So you're given like blocks. So you're given code and it's in blocks, and you have to order it so it makes sense. So this is just testing things like getting input before you use it and stuff like that, and scope. So obviously having your function prototypes at the top and then having your code. So you're given code, but you need to order them correctly. What else have we got? Sorry, it's not loading at the moment. So I'm just trying to remember. Some of the other stuff that we did. So the other thing that will definitely be on there. So this is, some of this will be on there. These will definitely be on there. These will definitely be on there. The other thing that will definitely be on there is a full program. Now, with a full program, you're not going to get steps like you do in the labs. It's not going to be as nice as in the labs. You're just going to get a problem. You do get some information. You'll have some constraints, so it'll say stuff like you must use malloc, or you must have 6 functions, or you must do this. It's not going to be extremely long. It's probably going to be a page or a page and a half, and it's written. Now, get experience writing it by hand. Don't do all your practice on a computer, because you'll forget syntax and stuff like that. Okay? So get practice writing full programs, give yourself little problems, and write some code. And that's basically the exam. Now it's going to be a bit of a challenge in terms of time, but you do have 2 hours and 15 minutes reading time. So if you pace yourself, you should be fine. Yeah. No, it won't be. So will it be like a lab? What do you mean, will it be like a lab? Ah, you guys haven't done exams before, have you? Keep forgetting. So, no, it won't be like a lab. So the lab gives you steps. This will give you a problem. So it'll be like the lab in terms of the problem part, but there won't be the step part, if that makes sense. So let me grab an example. They're not going to be as long as the labs, obviously. The labs are for 3 hours, and you've only got 2 hours. So it's only going to be a short little problem. It could be something like we saw the other week, the weighted mean function and have main, or something like that, or the quadratic function, the quadratic formula, and then something else and something else, maybe a couple of small maths functions, and then call it from main. It's a full program, so it will have main in it somewhere in your libraries and everything. But let's see. That's way too messy. So when I say a problem, and I'm not showing my screen, that's a problem. Okay, but it'll have a bit more stuff about the code as well. So it'll say you have to use malloc, you have to use this, you have to use that. Okay, this is one of the tasks we did earlier. It won't have this. Okay, it won't have steps. So it won't have any of this stuff. It'll just be a problem and some constraints. Okay. And it's all handwritten, it's all exam conditions. Sitting in a cold, big hall. And yeah, bring a jumper. So the halls get quiet. Cold. So that's the exam. As I said, I will write a practice exam. Hopefully 2 if I get enough time. But yeah, sound even funner. But yeah, it won't be as hard as the assignments, obviously. The assignments, you have all the tools next to you, where in the exam you won't. Now, one other thing, there is a couple of things that you do need to know, because they won't be given. So you do need to understand binary to hex and hex to binary. for at least, well, that's fine. And you should be able to go from binary to decimal and decimal to binary from 0 to 15. Okay? So it's expected that you know that. It's expected that you know the size of standard variables. So that won't be given. So actually, I'll grab the reference sheet. So you should know that a car is 1 byte. You're not expected to know the range, but you should know that a car is 1 byte and a short is 2 bytes. A long is 4. Okay. You should know that the float is at 4 and the double is 8. You should know your format specifiers, especially the common ones, so %C and D and F. Them three are pretty much some ones we've used the most. And %S is another one that may be on there. That's not on the sheet. I was going to write another sheet, I'm just running out of time. It's a good idea to go through these keywords, make sure you know most of them. Some of them we haven't covered in the subject. Escape sequences, you should know how to do /n. Okay. I would recommend possibly memorizing these as well. The ASCII table we'll talk about. You won't get an ASCII table, but you do need to understand how the letters relate to each other. So if I have M and I add 2, I end up at O. But I don't need to actually know the number. Okay, but you do need to understand that concept. This you need to know. Okay, except for the octal. You don't need to know the octal. I don't think. I'll double check that, but definitely binary, decimal, and hexadecimal. So you should be able to go from any number from binary to hex and hex to binary, and at least 0 to 15 for binary to decimal or decimal to binary. This you should know. It's not going to be given, so you should know the type conversions. You should know your bitwise stuff. Okay, it's not going to be given, so definitely remember that. You should know how to cast. That's not going to be given. Your literals, you should know. That's not going to be given. This, however, will be given in a slightly different format, but you're not expected to memorize the precedents. Indentation, yeah, you should know that by now. So there's a lot that you do need to know. Given the sheet, you don't need to know anything about Unix. You don't need to know how to compile. There's not going to be questions about Unix or compiling at all. So be aware of that. Does that help? Is there any questions about that? So the other thing that someone asked today, which was an excellent question, so my question to you is, are you still, just let me know if you're still there firstly, because I think a couple of people have left. And it's actually quite an important question. Still here. Okay. Cool. So I've got a question for you. Do you know what the do you know what the highest mark you can get and still fail the subject is? So highest subject mark whilst still failing. So this was actually quite an excellent question because most people don't read the subject learning guide, and it was mentioned early on. So you can still fail with a 74. And this is an odd case, very odd case, but you can still fail with a 74. And that's the highest that you can fail the subject with, because there is 3 hurdles. Okay. 50%, so greater or equal to 50% for non-examinable, greater or equal to 50% for exam, and then greater or equal to 50% subject. Okay, so if you get the 50% here, but you get 24% here, you still fail the subject. If you get, yeah, because you get 74. Okay. All right, so be aware of that. Unless that hurdles me. So what I might do is I might actually try and get that. I wonder if I could run it in. No, it's not Unix. So what I might do now is try and log into the Unix server, but it may crash the stream. Just to show you some examples. So the hurdle. And it's gone. So it's just 50% overall and 50% for the exam. So that's actually easier this year than last year. All right, cool. So we don't have to worry about that part. It's only 2 hurdles this year, which is kind of lame. No. Still, the 75% applies. Still, the 74, sorry. So, I'm going to try and log this to the server. If it works, then the stream log is still here. If it doesn't work, thank you for watching. And I'll see you on Saturday. And we'll have a bunch of stuff regarding the assignments and arrays and dynamic memory. Sound good? Unless there's some topic before I try this that you want to ask or question. All right, so I'm going to try this. If it works, I'll still be here, but it may cut the stream. Let's see. Okay, so that seemed to work. Do you get full credit points? Yeah, you get full credit points no matter what the subject. Credit points are just a measure of the completion status. So you always get full credit points. Well, the iron video works beautiful. So I'm going to that. Okay. All right, so actually I'll make the font a bit better. Appearance, 15. Is that readable? Okay, so let's wrap it up. I can't see the Google logo, so you have to tell me where it is. So this gets 8. So yours obviously won't have all this stuff here. Top right hand corner. So up here, no left. Okay. So I'll move this over a bit then. Now, is that okay? Really, it's not big. How's that? Bring it down a bit. Perfect, cool. All right, so you'll turn the this off. Okay. So the assignment will look something like this. So the first couple of stages, you'll just enter the board width, the board height, and the number of lines. And then you'll get asked to enter the values. So you enter the values. And here's a 1 for the X, a 1 for the Y, and a 0 to say that I'm going to select this. If I put a 1, then I'm talking about a flag. Okay? And so we can step through this, and you'll notice that this eventually gets through the whole thing, and we lose in this case. Okay? Now, there is a bunch of test cases up there. No, you don't. You don't get the AI. I'm not that nice. So you can see here, it's all filling up. You're going to have to type this or use the test cases. But you'll notice that it's fairly ugly as well. So I'm working on a couple of bonuses, which I'll show you, which make it look a lot nicer. So, we can see that, yeah, it's basically, where's the test cases then really nice. It's not a really nice test case. I really like the 12. 10. That looks nice. Okay. So you can see we're putting the values in and we're flagging every time we want. Obviously, you'd be entering this, and you can see we're setting the flags, and it gives us the numbers. For the bonus, you'll notice that the screen isn't moving at all, and you'll notice that we've got colors. There'll also be a couple of other things that you have to do for the bonus, which is write to file, and then there's another bonus which I haven't implemented yet, but I'll get to. Okay. But no, you won't be doing any AI or anything like that. I just did that so that I could generate heaps of examples that were real. Because obviously in this we can cheat, but if we cheat, it won't be a real case. And you won't get fails and wins. So that's just a little example. That's what you're going to be doing. And yeah, it's fairly nice. Right. Close that. And I'm going to so you don't actually need a program to input the samples. You just copy and paste. So, damn it, let's close that. So I'll show you an example. Sorry, I still have the computer. So I'll show you what I mean. So turn the bonus up. So with yours, you'll run your program and it looks something like that. Now, I will give you a file. So I'm not going to open that on the screen. Publish stuff on there. So, hopefully this works as it does. Cool. It doesn't include anyone else's work now. Okay. Cool. Okay, so you'll get a text file that looks something like this. It'll just have a bunch, and you can open this in any text program, and it will have all the test cases, okay, and all the text. And it'll be a .bin file. So this is test case 9. And all you do is you select everything, press Control-C, you come over to PuTTY, and you right-click, and this is into PuTTY, not into Unix, and it will run. Now you won't get the nice time delay, but it will stop if it crashes or breaks or whatever, and you can work out what went wrong. Okay? But if you right-click, it'll paste everything. And you can also just pick a bit of text and then right-click and paste that. Okay? So you will have access to do that. All right? But yeah, you won't have a nice little timer or anything like that. So you may want to input it one at a time while you're first getting on. And there'll be a video for each test case as well. And if you run out of test cases, I can make more. Cool. Sounds good. So get that started. And get the first stage done. As I said, there's already so get on it. Right, thanks guys. Is there any last minute questions? Are we done? Are we done? Yeah, Saturday I'll cover structs. I might start a little bit earlier too. I'll let you know if I do. Thank you. Yeah, stop. Cool. See ya.